Okay, this is kind of a lengthy problem, so bear with me. A crate is pulled by a force parallel to the incline up a rough incline. The crate has an initial speed of 1.5 meters per second. The 15-kilogram crate is pulled a distance of 7.5 meters on the 30-degree incline by a 150 Newton force. For part A, what is the change in kinetic energy of the crate? And for part B, what is the speed of the crate after it is pulled 7.5 meters? So, we also know that the friction coefficient of the friction is 0.3. So let's use the work energy principle. The change in kinetic energy, the change in kinetic energy is equal to the net work, which is equal to the applied work, minus the work done by gravity, minus the work done by friction. So let's first find the work done by the applied force. The applied force, the work done by the applied force, is equal to F times D, which is equal to 150 times 75, which is equal to 1125 joules. Now let's look at the work done against gravity. So the force along incline due to gravity, we want the vertical component. F is equal to the force done against gravity. F sub g is equal to mg sine of theta, which is equal to 15 times 9. Why did I put it as a decimal? 15 times 9.8 times sine of 30 degrees, which is equal to 73.5 newtons. The work against gravity is equal to F, force done by gravity, times D, which is equal to 73.5 times D, which is equal to 73.5 times 7.5, which is around 551.25 joules. Now step 3, work done against friction. So the normal force, we can look at the horizontal component as this. It's equal to mg cosine of theta, which is equal to 15 times 9.8 times cosine of 30 degrees, which is approximately 147 times 0.866, which is equal to 127.3 newtons. So the frictional force is equal to mu times the normal force, which is equal to 0.3 times 127.3, which is approximately 38.2 newtons. So the work against friction is equal to the force of friction times D, which is equal to 38.2 times 7.5, which is approximately 286.5 joules. Now, let's look at the net work, right? The change in kinetic energy. So I'll just start this right here. I'll use a different color. The change Why didn't it change? So the change in kinetic energy is equal to the applied work minus the work done by gravity minus the work done by friction. So that gives us the change in kinetic energy is equal to 1125 minus 551.25 minus 286.5, which is approximately 287.25 joules. So that is part A. Now let's erase all of this. Let's find the final speed. So, the change in kinetic energy is equal to 1/2 mv final squared minus 1/2 mv initial squared, which shows us as 287, which is equal to 0.5 times 15 times v final squared minus 0.5 times 15 times 1.5 squared. So let's find the initial kinetic energy. The initial kinetic energy is equal to 0.5 times 15 times 2.25, which is equal to 16.875. 0.5 times 15 times v final squared is equal to 287 plus 16.875, which is equal to 303.875. 7.5 times v final squared is equal to 303.875, which, solving for v squared final, v final squared is equal to 303.875 divided by 7.5, which is approximately 40.5167. Therefore, the final velocity is equal to the square root of that, which 40.5167, which is approximately 6.36 meters per second. That is the answer for part B.